Hello, 6th hour calculus class. Today we will be discussing integration and its meaning. To begin, let's discuss the verbal definition of integration. Courtesy of Wolfram Math, an integral is a mathematical object that can be interpreted as an area or a generalization of an area. Integrals, together with derivatives, are the fundamental objects of calculus. Other words for integral include antiderivative and primitive. The Riemann integral is the simplest integral definition and the only one usually encountered in physics and elementary calculus. Next, let's discuss a graphical meaning of integration. As you can see in the photo, integration is the area under a curve set between 2 points. In this case, those points are B and C. As the curve goes on, area in some places can become smaller or larger, thus needing 2 points to act as boundaries, as B and C do in this situation. An integral is an opposite of a derivative. So symbolically, f of x equals the integral of function f prime of x over the interval b to a, which is the set of points that you want to find the area between. The definite integral is defined informally as the signed area of the region in the xy plane that is bounded by the graph of f. The indefinite integral is the exact same thing, but it has no boundaries. The signed area means that the signed area is the area above and below the x-axis being subtracted. So if there's an area of 5 above and an area of 3 below, the total area is 2. Total area is all the areas added together. So, same example, there's 5 above and 3 below, the total area is 8. Whether it is positive or negative does not matter. On indefinite integrals, remember to always add plus c to the end because there's no bounds, so you can technically not solve. The c is definitely important. By the way, Calc fam, don't forget them cookies.
Riemann sums can be used to describe the area under the curve. This can be done by dividing the section into rectangles and finding the areas of the separate rectangles. The right-hand sum is an over-approximation and the left-hand is an under-approximation. The midpoint evaluation is the average of the two and is the most accurate. Use this formula for Riemann sum approximations.
According to Wolfram Math, the first fundamental theorem of calculus states that if f is continuous on the closed interval a to b, and f is the indefinite integral of f on a to b, then the following formula is true. This means to solve for the integral on the interval ab, just take the integral of the formula f of x and plug in the bigger value first, which would be b in this scenario, and then subtract the smaller value off, which would be a, to get the final area between the 2 points.
In examples A and B, when taking the integral of two functions being added or subtracted, you must split the integral into two separate integrals, then add or subtract. In example C, when a function is multiplied by a constant, the constant can be placed out front of the integral and can be multiplied after the integration. For example D, just combine A and C. When integrating a function with a power, add 1 to the exponent and divide by the new power. By reversing any derivative formula, we get a corresponding integration formula.
The integral mean value theorem states that if f of x is a continuous function on the closed interval of a to b, then there exists a number c in that interval such that f of c equals 1 over b minus a times the integral of a to b of such function f of x. This formula is really straightforward if you follow the pattern it displays. For example, let's say you have a function of x cubed and its boundaries are 2 and 4. This is the graph of x cubed. Just plug everything in like the picture shows and solve for in the mean value theorem. It should be between the minimum and maximum. According to Wolfram Math, the second fundamental theorem of calculus holds for f, a continuous function on an open interval I and a, any point in I, and states that if f is defined by the integral f of x equals integral of f of t on the boundary x to a, then f prime of x equals f of x at each point in I, where f prime of x is the derivative of f of x. This means that the definite integral of any function can be found by utilizing any one of its many antiderivatives. For example, in the problem shown, the main f of x function is found by taking the derivative of f of x function and showing that they are equal.